So greetings, my name is Steve Holliday from ASTM, and I'm pleased to introduce this next presentation, which is the customer panel. The title of this session is Tools Used by Engineers, but for the sake of SDOs and NSBs on this call, we added, and what the heck are you doing with our standards? The good news is our panel is dying to tell us all just that. So the idea here, briefly, I'll just sort of introduce what the whole idea of what's going to happen here is. We have a hand-picked customer panel of speakers who actually do the work with our standards, not just talk about them, but they actually work with them. What do they look for when they're using them? What tools do they use? What does the workflow look like when an important standard changes for them? You know, you get the idea here. So today's panel guests consist of Katie Moss from Denver Water, Paul Gill from NASA, and finally Abram Hudson from Barrios and Encosi. Each session will be a brief 15 minutes with 30 minutes for questions at the end. Since we have 4 guests, please direct your questions to a specific guest so we know who to direct that to at the end. So let's get started. Our next speaker is Katie Ross from Denver Water. And Katie, I'll turn it right over to you, okay? Thank you.
Okay, thank you. Thanks for having me this morning. My role within Denver Water is the Distribution Engineering Manager. I've been here 10 years, and I have 3 pretty distinct roles. One is I manage our main replacement program, which is very organizational facing. I manage our plan review program, which is developer facing. And then I marry those 2 assets by managing the development and publication of our standards. So as an organization, Denver Water has 1,200 employees spread across the state. Of the 1.5 million people, we actually serve 25% of the state's population, and that includes 62 distributors, which are under a contract with Denver Water that covers the city and county of Denver and the Denver metropolitan area. One of the things that's a little bit more unique about Denver Water is we're actually the 3rd largest landowner in the state behind the federal government and the state of Colorado. And our watershed is split between the South Platte and Colorado River basins. As an institution, Denver Water has a really strong history of relying on SDOs. The first known publication of us referencing industry standards comes from the Chief Engineer Standards, which was published in 1959. As an organization, we were formalized in 1918. However, we have assets still in our system that date back to the late 1800s. While the 1959 document gave us a really public way of acknowledging different standards organizations, we know that from the late 1800s until 1959, we had references to AWWA throughout our legacy documents. As it stands today, our library has evolved pretty substantially. We have standards publications that covers everything from CAD documentation required to do business by or for Denver Water, covered that references national CAD standards. Our capital projects construction standards is a deliverable that we produce every 3 to 4 years. The current publication has over 260 technical specifications and 500 standard details. And this document is used for the capital delivery of our system. And the last document is what the Chief Engineer Standards evolved to. So now we're in the 15th edition of our engineering standards. It's the most public-facing document that we have in that it covers pipe 20 inch and smaller, and it covers service lines. And as every homeowner knows, you have your own service line, and that's how we tell people, no, you cannot use a garden hose for your plumbing fixtures. And so it's a pretty valuable document that we rely on. The evolution from 1959 to 2020 is reliant specifically with organizational support. How we implement the standards really starts from top down. Prior to, I think, 10 years ago, we didn't formally look at continuous improvement. We've had standards to establish a legacy of work. We've had standards to drive safety, which is first and foremost for any of our projects. Both public and employee safety. And as we've evolved, we look at our standards to help drive our scope, schedule, budget of that capital delivery. And all of that leads to more efficiency. It's interesting, we get a lot of questions from other water utilities, not even water, just other utilities in general. How does Denver Water have such support for such a broad variety of standards adoption? And that really starts with our executive leadership. Through our executive leadership, we've identified subject matter experts. What I love about Denver Water is our experts are not specific to engineering. We put as much value on a field employee's input as we do on a 20-year engineer. There's some technical requirements that we have to always vet, but there's also that field aspect that we never diminish. And we take all of that subject matter expert input, and that's how we establish our specifications used in the CPCS. When we do these publications of the CPCS, every reference used in every specification is reviewed by an engineer. And that engineer reviews to make sure that if, let's say AWWA C111 has republished from the prior edition, we'll look at it, verify that there hasn't been any changes detrimental to our spec, and then we'll adopt it, or we'll choose not to adopt it. And so, you know, you can see through our specifications, we rely on every SDO that's available for our work. Because we have this great library, our standards adherence, it does not happen in a silo. It can't be engineering telling our field staff, this is the way you're going to do it. It can't be our field staff saying, well, I don't care, that's what you want, we're going to do it our way. It has to come from the executive leadership down, and it really starts with education. Education with our field staff, education from engineers. We get in a room, we talk about it. And then the biggest aspect of my role is to educate the public. Denver Water is strictly a water utility, but that doesn't mean that we don't ignore our peer code authorities. We participate in building code amendment reviews with the City and County of Denver. We participate with NFPA adoption with various fire districts. And the biggest aspect of that is we work with our distributors to educate them. And we really have a common language with manufacturers as we go through establishing stock product. Our interaction with SDOs is actually pretty varied across the organization. The obvious participation comes from AWWA and ASCE. We have many, many employees that are on AWWA committees, but we also have strong participation and involvement with ACI, with NACE. ASCE conferences is a big part of what we do. And as in my role and in the development of our library, the standards interface is pretty key to that success. Since the evolution of ASTM Compass and now AWWA Envoy, we're far more efficient in looking at the latest documentation that we need to use within our organization. And then that code amendment review is a little bit unique in that, you know, a good example is when marijuana became legalized in the state of Colorado. As a water utility, you wouldn't think that that would impact our operations or maintenance, but with different fire requirements, different electrical requirements, we actually got heavily involved with those code amendments for IBC. I would say the biggest evolution within our organization has been procurement. We now have a very uniform process with purchasing specifications. Continuous improvement has taken us to a just-in-time delivery. 10 years ago, we had a stronger warehouse supply than any of the local suppliers through Ferguson or HD Supply. We were the supply house that utilities would go to if they needed a product. On that flip side, we were also really good at making things really expensive for us because we didn't necessarily just adopt the latest AWWA standard. And so as we've taken a step back and said, let's make the standards work for us, that's allowed us to become far more efficient in our procurement process. It's created more competition in our pricing. We now tie our commodities and any material that's tied to a commodity index. We've got a really clean financial view with our board. Our diversity program, we have some peer standards we rely on for that supplier diversity program. And the biggest thing is we rely on consistency. It gives us that consistency of different materials that are going into our warehouse. One of the unique things about Denver Water is that we actually don't allow the use of approved equal products. A lot of construction products, widget A, might cost X, but if I'm a contractor and I can get widget B for half the price, that's the one I'm going to use. However, Denver Water standards have a very select list of manufacturers that are approved for use in our system. And we establish that list through our materials review committee. The first and foremost criteria is we look at compliance with applicable AWWA, ASTM, and ANSI standards. By having that bare minimum, we now have the ability to take that and figure out if it's going to be a good fit in the system. With ASTM, we rely on it to give us a common language with testing protocols. Denver Water has a good partnership with the University of Colorado's Center for Infrastructure and Energy and Space Testing. We will take product that we are considering for use in our system, take it up to Professor Wam. He will look at it. He will establish that testing protocol based on the ASTM guidelines. We'll establish that minimum test criteria, and the end results gives transparency to not just the manufacturer who's requesting us to look at the product, but any of the peers that are already approved in our system. The other benefit of relying on a standard such as AWWAC 111 is it gives us a good analysis of supply chain impacts. We can tell if it's going to be such a unique product, we're going to have a hard time keeping up with supply and demand, or if we have that reliability into it, we can kind of guarantee that if in an emergency, we won't be stuck. So, it's good to talk about having a standard, but how do you measure the success of the standard? Denver Water has a capital burn rate of about $150 million annually just on system maintenance. In addition to that, our board is not interested in deferring any type of system improvement. So for the foreseeable future, I would say about 10 years, our capital budget, our CIP is about $350 million annually. That's a pretty big increase in a capital budget that has fairly consistent staffing levels. That 1,200 employee staffing level has not changed. I would say, at least in my tenure, I have not seen it change by maybe 10 employees plus or minus. And so the only way you can increase that capital budget expenditure is by increasing your efficiency. And we increase our efficiency by relying heavily on those standards and those specifications that we work to establish. The end goal for any water utility is to ensure safe and reliable drinking water. The more we rely on our SDOs, the more that allows us to meet that end goal. One of the uniquenesses of Denver Water is that we just celebrated our 100-year anniversary in 2018. I mentioned that we have assets dating back to the late 1800s. We actually just finally replaced a main in downtown Denver that was from 1876. And while it's impressive that we have assets that date back that long, it's really a testament to the innovation and the foresight from our forefathers. They relied on standards, as you know, in the 1950s, the 1940s, the 1930s. By them establishing those minimum standards, they gave us a fairly strong benchmark to follow. When we look at the future, our future is driven by the adoption of our library. The more we can use the library to publish why we do what we do, the more we can inform the employee in 50 years. And the best way to consider how Denver Water looks at any type of adoption of a new standard is we'll review it. We'll get the subject matter experts to review it. At that time, we'll choose to adopt it. A good example is, a digital register. Do you want to use that for your billing or not? We've chosen not to, so we didn't adopt it. Others we adopt immediately. Once it's adopted, then we educate. We educate our employees. We educate office staff. We educate field staff. And then lastly, we promote it. We promote it within the community. We promote it to developers. We promote it to manufacturers. We promote it to the suppliers in the area. And through that, we've had pretty successful results. This is our last building that we did of our campus redevelopment. It was a $180 million project, and you couldn't do this project without the involvement and the reliance on SDOs. And with that, I'm done. Any questions, feel free to put it in the chat, and thank you.
All right, thank you very much, Katie. That was very interesting and really appreciate that. Our next speaker will be Paul Gill from NASA, and thank you very much, Paul. We're looking forward to this.
So my name is Paul Gill. I manage the NASA's technical standards program for the agency, and I have been doing that for a while. And also part of my job is to basically lead the model-based system engineering initiative as well. So for today, we'll focus on the NASA technical standards program. If you're not familiar with NASA, so this is basically a kind of a geographical layout of all NASA installations. Pretty much, you can see there are but 10 NASA centers from east coast to west. These centers are basically broken up into 3 mission directorates. So the centers are broken up into 3 mission directorates. So we have aeronautics, then we have HEO, human exploration and operations, and the science. So the HEO mission director is probably the largest director we have. We have International Space Station under it. We have multi-purpose crew vehicle. We're building a space launch system under the mission directorate. And of course, the Gateway, our next space station, there will be an outpost for orbiting the moon, and the HEMO landing system. So HEO is the largest user of our technical standards as well. And then there's science is basically is conducted at a Goddard Space Flight Center at Maryland, then of course JPL in California, and HEO is basically Johnson Space Center in Houston and Marshall Space Flight Center in Huntsville. That's where I'm located, and the Kennedy Space Center is our launch operations. And aeronautics is basically the Langley Research Center in Virginia and Glenn Research Center in Ohio. So that's pretty much the breakout of our mission directors and our geographical installations. So let's focus a little bit on our technical standards program objectives. So first and foremost, the whole objective of our program is to provide technical excellence through standardization. Basically mission success, mitigating risk, and things like that. As other government agencies, we are required to comply with Public Law 104-113 and the implementation of OMB Circular A119, where all federal agencies are or must use voluntary consensus standards to a degree practical in lieu of government standards. And I'll talk a little bit more about that as how we're complying with the law. And again, we as an agency, we can't always use industry standards or voluntary consensus standards. So we do develop NASA standards as they're unique to our needs. There's some standards where we look at deep space network, we look at other things, maybe from the materials perspective, where societies right now actually don't have those standards. So we do still develop some NASA standards as well. Again, in compliance with the OMB Circular A119, we basically provide a NASA resource, a web-based interface for many NASA standards as well as industry standards as a single access point. And I'll touch on that a little bit more into the presentation. So again, focusing on the A119, a little bit more on that. We first and foremost, before we develop a NASA standards, we basically go out and assess what is out there. Is there a comparable voluntary consensus standard that we can use without having to develop our own? Can that voluntary consensus standard be tailored? So to every extent possible, we try to look for a society standards to do our job. We also encourage our employees to participate, and the contractors as well, participate on societies, on committees, and be proactive in that area as well. Also, we encourage people to revise. Anytime there's a voluntary consensus standard that's being revised, I encourage our guys to participate on the committees as well. I think we have close to maybe 100+ employees annually actively participating on committees, over 140, 150 committees. We report to Congress or through NIST every year, as to how we are doing in terms of complying with the OMB Circular A119. So in the cases where there is not a comparable standard, so we have developed NASA standards and handbooks. So we have about close to 100 NASA technical standards in the certain technical discipline areas, as you guys can see on the right side. Again, this is another example of where we use society standards. Mainly with the SLS, for example, these are some of our large flagship programs, excuse me, where many standards are being used. So we don't just use standards at the very beginning of the design. We use industry standards throughout the whole life cycle of the program, all the way to decommission. So as we start a new project, there's very few standards that are identified, and as we progress, so we keep adopting industry standards to be applied on the program project. And many of our standards, our programs have mission times of 25 years or 30 years, like the space station or the shuttle program. So we still have to have access to industry standards that were used in the historical standards. So we have to have access to those standards as well. So it's an iterative process. As the program matures, sort of use our technical standards. So how do we apply NASA standards? 90% of the time, we never levy a standard as a whole. We basically develop program project unique documents where we basically call out an industry standard or a specific section of that industry standards. And that is done through our technical discipline experts. They'll identify the specs and standards that are applicable to the program or project. So that's the beginning of how they're selected. Again, keeping in mind, first and foremost, we'll look for an industry standard or a voluntary consensus standard, see if there's available. If not, then we look for our internal standards to be used. And in many cases, like I said, programs don't use standards as a whole, so they go through the deviations and tailoring process. So we have a process called Tech Authority, which Tech Authority is basically an independent authority from the programs and projects, mainly for the purpose of checks and balance. So anytime there is a tailoring of a standard on a program, it has to go through Tech Authority. And through the chain of command, if the programs and the Tech Authority does not agree, it gets elevated to a higher level. That Tech Authority was put in place after the Columbia incident back in 2003. So we have programs and projects, basically identifying standards through technical experts. And if we have to make a decision between what the contractor is proposing and what NASA is proposing, that's where Tech Authority comes into play to basically to resolve any issues we may have. A Tech Authority is basically the decision authority that we end up going with based on technical risks and things like that. And also in our standards, we have a process in place for tailoring verification requirements. On many NASA standards, I think it's all of them now, we basically have a requirements compliance matrix. Our standards are pretty generic. They're not that prescriptive in some cases. So we do identify in the resolution compliance matrix which requirements apply to which program. So if you look at a NASA standards, in the back of the NASA standard, you will see this compliance matrix where a program can pick and choose on which requirements do apply. So that's kind of how this standards are being applied. And like I say, this is an iterative process and it goes throughout the entire life cycle. Talk a little bit about single point access or web-based environment. For the last 15 years or so, we've had a single point access to standards. I think we have close to maybe, I would say, about 1 million documents available to our users across the agency on demand. It includes NASA standards, includes center-specific standards from a major 25 SDOs. And if they can't find a standard as a subscription, we have a process called pay by the doc, and a user can order a document without having to pay for it. The program is pretty much funded out of the NASA Chief Engineer's office up in Washington, and that's the office I report to. So we pretty much have a single point of resource to manage the program, and also fund the system itself. We also have access to one thing unique about our system is we try to identify lessons learned across the. We have a lesson learned database. So anytime there's a lessons learned developed, we try to find a standard that it may be applicable to. So when the user goes in to get a standard, they can also get a copy of the lessons learned that may be applicable for the work they're doing. Also have access to a lot of the other databases like the parts, logistics, bill of materials. All NASA standards are available to publicly accessible, and you can download them and use them as you wish. On the right side, it just kind of gives you an idea the volume of how many standards are being used annually, and how many use. So as you can see, we progressively increasing the use of industry standards. Back in 2016 with 107,000 downloads, last year with 112,000 downloads. So we are relying more and more on society standards as well. Okay, so let's kind of shifting gear a little bit. One of the things that we're doing at the agency, we just kicked off a digital transformation initiative across the agency, and it has 6 different elements to it. One is data, one is I think AI, machine language. There's a process element to it as well, workforce. So the two of the 6 that are really kind of interesting to us, to me at least, is the data piece and the model-based X, we call it, model-based everything. So we're very document-centric still at this agency. We rely on PDF format for our folks to use. So what we're trying to do is we want to get to a point, and this doesn't exist right now. So I'm looking for the societies to help us kind of identify how do we become more data-centric versus document-centric. And some of the challenges that we face going data-centric is discovery of standards in an enterprise architecture environment, the PLM tools. We have multiple PLM tools. How do we trace our requirements bi-directional in the program, and where the requirement came from? Like I said, we don't use ASTM standard as a whole or SAE standard as a whole. We create a project-specific document, and in some of those project-specific documents, the requirements came from an industry standard. So we want to have the traceability back to where the requirement originally came from in case the standard gets updated. So we're very much interested in having an enterprise architecture in place or common interest place, as well as a way to link our standards requirements through the enterprise. So data interoperability is really important for us from the model-based system engineering perspective in the PLM. We don't have the luxury, as some of the industry folks do, to go to a single vendor, for example, for the PLM. We have quite a bit of PTC Windchill tools here. We're about to get some of the Team Center stuff, so we don't have the luxury of dictating to a supplier which PLM tool to use. So we have to look for a way to be more data interoperable between the tools, and also that complicates us a little bit. How do we trace our standards back through those multiple different suites of tools that may not be compatible with each other? How do we prioritize investments? Where do we get the money to basically go in that direction as far as managing our standards to the challenge? And last one is how do we keep our data secure? Digital rights management. So we are actually dealing with that now. We just awarded a contract to a third-party supplier a couple of months back, and most of the societies are now requiring the DRM capability. So we are trying to understand which plugins and which apps we need to deploy at the agency level. So we're still complying with the copyright laws and not violating copyright laws. So the DRM is a big thing for us. So we're still trying to sort through that as well. So at the end of the day, I think we're going to get there, but we're not quite there yet. And I look to the societies to help us go in that direction as to what they're doing when it comes to treating the documents as data. Again, thank you for the invitation. And any questions that you guys might have, let me know.
Okay, thank you very much, Paul. We really appreciate that. That's very interesting also. And last but not least, we have Abram Hudson of Barrios and Nkosi. And we're also looking very much forward to this too. So thank you, Abe, for attending, and please proceed.
All right, thank you, Steve. So yes, my name is Abe Hudson. I'm a systems engineer at Barrios Technology. The first 11 years, I worked on the space shuttle avionics software as a requirements analyst. And since 2014, I've been more involved in oil and gas. So I've got a foot in both. Both of those industries are prominent here in Houston. So that's my background. I'm also heavily involved in Nkosi, and a lot of what I'll be presenting today is both my experience with standards and systems engineering and sort of recommendations based on Nkosi guidelines. So the first challenge with standards and systems engineering is making those standards available in a format that requirements management tools can consume. And I think next slide gives us an example of, well, so first of all, let me speak to why we would want to use a requirements management tool versus a Word document. And so when I started as a requirements engineer on the avionics program, we did start with Microsoft Word, and we did a lot. And at some point, we did migrate the content of those requirements from Word into a requirements management tool. So with a Word document, and we've all done this, it's 1D, it's up and down, you get requirements, and that's pretty much it. If you're using a spreadsheet, and some people do that as well, you get an additional dimension where you have your content, and then off to the side, you can create some columns and define some attributes, and that's a little better. But it doesn't address the other important aspect of requirements management, and that's creating the traceability. And that's where we get the third dimension for a requirements management tool. And so this is why if you're working on a complex system, you really need a tool dedicated to managing requirements. So this is an example of a requirements management tool with a few requirements. And as you can see, it pretty much looks just like a document. You have the layout, you have heading numbers there. You do have some rows and some columns, so you know it's getting the look and feel of a spreadsheet. But you also, if you'll notice, that there's a unique ID column there, and I like to explain that as it's sort of like a requirements social security number. I can move a requirement around anywhere in the layout of a particular document, and that ID goes with it. It follows it, and that's what allows us to do the traceability between this particular requirement. I believe this example is for stakeholder requirements, and so typically you'll want to start with the high-level stakeholder requirements, and then you'll want to develop system requirements that satisfy those, and you want to create those links. And here's an example of that. These are system requirements, and you'll see there in the blue, those are the stakeholder requirements that they're traced to. And you do this for two reasons. If you notice that you don't have any stakeholder requirements traced to a system requirement, that can indicate that there's a gap, that a stakeholder requirement may not be implemented. Also, if all of your stakeholder requirements are traced to, but you have system requirements that don't have a trace back up, then that could indicate that you have system requirements that you potentially don't need. They're not mapping back to a higher level, so you have to investigate, why that gap is there. Some of the other things that you'll see is, the attributes. You can define, priority, stability, and that really just helps you manage the requirement. So this is the environment that systems engineers usually they start with the requirements. That's the foundation of a project. And if you make mistakes here, then they're going to propagate, and they're much more expensive to fix in the long run. So these tools are critical, and also frequently standards play a part in this this dynamic. The problem with standards, though, in my experience, and this has primarily been in the oil and gas industry, is that when we get a standard, it's in the format of a PDF, and this is a locked PDF, no printing, obviously, also no copying and pasting. It's a true read-only format. Maybe not all standards are this way, but some of the ones that I've worked with were. So this is very difficult to manage the compliance to these standards, basically because I can't get these standards into this requirements management system. So we want these standards in there because we want to show the compliance, the traceability, just as we had done with the stakeholder to system requirements. We want to show that the system requirements are mapping to the standards as well. And when we can't do that, then we can't check these off. It's like having a checklist that's in the paragraph format. It's all or nothing, and it's very difficult to do that when you have thousands of requirements. So currently, standards in the PDF format they're kind of, you can open them up and you can read them for understanding and knowledge, but the management, the compliance management isn't supported, and that's obviously a challenge. So the second challenge, though, if we can imagine that we can get these standards in, and maybe there are some standards out there that are in an open Word document and you can easily import those into your tool. The second challenge is the way some standards are written. And to address that issue, I'm going to try to talk about a couple of examples that INCOSE gives for writing better requirements. Because in my opinion, requirements and standards are synonymous. That they're typically any standards document are going to contain requirements. So here are the characteristics, according to INCOSE, of well-formed requirements. So I think in many cases, the requirements I've encountered are largely compliant with these characteristics. The only problem would be that they're not singular, and so it's the singularity factor that I would like to address as probably the biggest improvement that standards can be improved by. So very generally, the accuracy of a requirement, it's really just based on this subject verb object format. ISO actually has a suggestion for a more complete sentence structure, and I've presented this before, and usually there's at least one person that comes up afterwards and says that they really like the idea of constraining the way a requirement is written. So if, the problem is we tend to be a bit more creative in how we write requirements. We write from a technical writing perspective, and we try to be efficient. And the problem with that is that efficiency is great, but it doesn't help you with the management of the requirement. And so here are several examples of event-driven requirements behavior-driven requirements, state-driven requirements, and an example of a requirement with a qualification. So you can do a lot with this structure. It feels limiting at first, but if this is how you write your requirements, you'll be in pretty good shape. So I mentioned singularity earlier. The problem is that commonly this is overlooked in its importance, mostly because most people aren't aware of that systems engineering need for traceability and allocation, validation and verification of a requirement. So the gist of it is that a single requirement should have a single thought. And if you need additional, some things are more complex and they may require sub elements, but that's okay as long as they're separate. So here's an example of an unacceptable requirement regarding singularity, and the control. So the example is the control system will close the inlet valve until the temperature has reached 85 degrees Celsius when it will reopen. And I think most people will read something like this and they understand it and they don't see a problem. And that's because we're reading for knowledge. The problem actually is that there's some ambiguity in here, and it technically contains two independent thoughts. What happens when we're above 85 degrees and what happens when we're at or below. So there's multiple problems here, but the biggest as far as singularity is that this is really two requirements written as one. And if I'm going to assign an attribute to this, it's difficult because I have two requirements here. They may have different values in whether there's a high risk or low risk, and so that's the problem. And sometimes this is just a sentence example. Sometimes we have requirements that are written in a paragraph format, and it becomes even more challenging. But this is a very basic example, and so a better requirement would be, here we have this split up in two separate requirements. What happens when we're above 85, and what happens when we're at or below. And so this allows for independent allocation for resources. The verification of these two are going to be separate. So when I do a verification test case, I can separate these out, and there's no ambiguity as to exactly what I'm testing, and whether one part of this requirement in the previous example could have passed, and the other had failed. And it's a challenge to manage that in that format. So the biggest part is just being able to write these in very singular forms. This is probably one of the most common formats that I've seen, but both and this isn't a standards problem. Let me just be clear. It's both people's requirements are written this way, in addition to standards as well. These are common mistakes just writing requirements in general. But I have seen this where we lead in with in the event of a fire, and then we have sub bullets. So in a systems engineering tool, I either have to bring all of this in as one row of data, which obviously makes it very difficult to do the allocation. These three bullets are very distinct, related to a fire, but also very distinct. And so I can't really do the traceability and allocation that I need to in that form. The problem is if I break this up, and this is what some people do, they'll break this up to where that first requirement says in the event of a fire, and that's not really even a requirement, and nobody really traces to that. What they do is they have the lower parts there that says power, and security and fire escape doors, and those are individually traced to. But the problem there is when you run a report, you're not seeing a requirement. You're seeing this fragment of a requirement, and you're not getting the context, and so it makes it difficult to manage that. And so that's why this particular format is difficult to work with. This is, and it's as simple as just writing these out. And so good requirements are repetitious. They they're not efficient, and they're tedious to read for knowledge. But this is the format that both requirements and standards should be in, so that you can have that proper allocation. So there are actually 41 rules that NCOSE has for writing good requirements, and you don't necessarily have to do them all, but singularity is a starting point. So if I could have anything, it would be that standards be managed and written in a requirements management tool, such that they could be exported out in a RecIF format, and that's a standard open format that anyone can implement. And multiple tools. I think Gerard earlier had mentioned Polarian. Many people, I think they're at NASA, they use Doors. All of these tools will generally accept this format, and you can easily import them in. Now, it's not locked, and so I think that's the biggest challenge, is how do you protect the content? But it would be nice to be able to import the standards into the tools using this format, and also that they're written in a way using the NCOSE guidelines, so that the allocation and traceability is there. And so that I know there are a lot of challenges to do that, but if I could have anything, that's what I would ask for in standards.
Okay, thank you, Abe. Really appreciate that. So yeah, we're a little bit over, but I think it was worth it for us all to do this. I appreciate all the attendees taking the time to go over a little bit. We do have a question session here, so I'll just go until I'm cut off on that, and I'll start some of those now. So I'm gonna have to read these sort of as I go, as they were published here. But one of the questions I was asked is, all customers, please comment on the value of knowing about standards in the works. In other words, pre-normative approval. You guys can just sort of talk about that. I see that Katie's already answered this, so we're gonna have some of these with answers here, but I think it's still important to go over some of these. So maybe Katie, you could sort of summarize your answer real quick for those that maybe aren't on video or on audio only.
Sure. So it's very important for Denver Water to have advanced warning. That's why we have so many committee participants. Anything lead related right now in this current environment is we're even more diligent, but by having that advance warning with the change several years ago to no lead for the brass and bronze goods, where the copper alloy changed, that allowed us to get ahead of our supply chain. More than that, it allowed us to educate. We had lead testing kits that we gave to inspectors, so if a material was on site that wasn't provided by Denver Water, we could check it. But that type of a change has a dramatic impact to the organization. So the more we can have advanced warning, the better it helps us. And with most of the manufacturers and suppliers going to just-in-time delivery, having that advanced warning helps get ahead of any supply chain issues. I mean, that's what we're really getting down to, right? In this global environment, a lot of imports are still coming in from Asia and India, and if you lose months of a standards change and adoption, then that could really kind of clog up the construction side of it.
Yeah. Okay. Well, that's great. I know, Abe, the answer for you too, because we've done a lot of things together already. But could you just do a quick comment on the same question, please?
As far as advance notice on the changes,
right, just what's coming down the pike. Like, we're getting ready to do a new release of document X, and knowing that ahead of time, how would that affect your workflow, for example?
Yeah, I think currently the way and that's obviously very helpful. The problem I think that we have is that when a change comes, and we know we have to prepare what projects would be impacted, and in many cases, if you want to know what's changed with an update, you have to go in line by line and do a lot of work to get that. Maybe, I don't know if all standards are that way, but in many of the ones that we work with, it's very tedious, and so you gotta prepare for that, and set aside those resources, which is again another reason why if if there were, and we could reduce that if there was a way to kind of see what's actually changed, without having to do all that manual work. Now, in some cases, in many of the oil and gas standards, the industry is actually involved. They help produce those, and so we get somewhat of an advance notice with that, and being involved is certainly helpful, because all the companies have a representative, and they'll come back and they'll let everyone know. So, but it is very labor intensive currently, so the more notice, the better, certainly.
Okay, that's great. Thank you very much. And I have a question coming up for you, Paul, but right before that, I wanted to jump something real quick for Abe. And Abe, this was put forth by Robert, part of this this panel here. And could you envision a machine requirement version of a standard and a human for knowledge version? So maybe you could discuss that real quick before I go to Paul.
Yeah, sure. That's a great question, because I think both are possible. Most of these requirements management tools will allow you to generate a document, whether that be Word or PDF, and it can look exactly like what we have today. But you can also generate a version that's in this RecIF format that can be consumed by the requirements management tools. So you don't have to make a compromise. You can have both.
Okay, great. So Paul, real quick here, how would could you talk about like how you would like us to deliver standards in the future? I mean, what do you like? What do you dislike? What we do now, how can we improve that? I mean, of course, this is sort of an SDO NSB type of a discussion here. We're really here to learn from you, and what can we do better to help you in the standards? And of course, I'll mention real quick, I think Tom Shortle made that all very clear. So we do understand that during that presentation, but maybe you can comment yourself, please.
Yeah, that's a tough one. Again, we're getting toward the digital transformation initiative. So having technical standards in the form of data is something that we're really interested in. So again, the downside of that is, like I said, we don't have a luxury of having a common architecture. I think from the requirements management tool, like doors to windshield, making that connectivity. So I think starting with maybe XML is a good way to make those standards available in their format. And I really don't know from XML, are there different APIs that we could purchase or develop that'll basically give us those standards requirements into this digital thread that we're trying to work toward. So right. I think XML is probably a good start.
Yeah, and probably related along those lines. I mean, I'm thinking other formats might be very important too, like RecIF. I mean, we know, talking with system engineers in conferences that a lot of us have attended, that one of the first things you guys have to do is take our standards and flip them into this, get them converted into RecIF, or for example, to work with doors or Polarian. So maybe you guys could talk some, probably Abe or Paul or Harold, anyone talk about other formats like that, like RecIF. Is RecIF, is that a format that we should be looking to help deliver to you, or is that something that you need to personally massage that into that format yourself?
So RecIF is XML, but it's a very specific implementation. It's
Right.
just the tags are very specific. So I mean, I agree. I think there should be a way to integrate, you know, in Paul's environment with wind chill. You know, if NASA wanted to use one of the requirements management tools to develop and manage their standards, then they could get a RecIF export in the XML format that they could import into other environments. That's one implementation. It's probably not the only one, but I think there are methods currently available. XML, regardless of whether it's RecIF or not, is probably the best way to go. But being that RecIF is kind of an open standard, and there's been a lot of legwork that's been done to make sure that's interoperable, it's probably a good way to you know, it's probably the best way at the moment. Now, there are other open standards that you could use as well for connectivity that's more direct. RecIF is an export, you know, it's an XML file, but there are other protocols that could be used as well. And so multiple options as far as I'm concerned that could solve these challenges.
Okay. We're sort of doing this on the fly here. I'm not sure about how we are on time. Hing, are we still open to go a little more, or we need to wrap this up?
I think you got a little bit more. There's a lot of interest, so it's good.
Okay, good. I see we have another question from Anonymous that was published. Are there any alternatives to RecIF? Sorry to keep on the RecIF thing, by the way, but are there any alternatives to RecIF for exchange or requirements between the requirement tools? And when can we get the standard into this format? So I don't know who would be answering that one. Anyone want to have a go at that one? Alternatives to RecIF, in short.
Okay, so RecIF is really for, you know, the file exchange. If you wanted, that's the big one. The other one is the protocol I mentioned earlier, and that's I think it's referred to as the Open Services Lifecycle Collaboration. And these will let different tools talk to each other in the systems engineering realm. So if you have tool A that you want to use for requirements, but you have tool B that you want to use for architecture, then if they both use the OSLC protocol, then you can connect those. And that's exactly what they do at Johnson Space Center. They use DOORS for requirements, but they use Magic Draw for architecture. And the architecture tool brings in these requirements without the use of RecIF because it has a direct connection. And so, you know, this has kind of already been, this is an old issue, and OSLC and RecIF are really the two main platforms that the SC community has used to address those. Now, there may be others, but those are the two big ones that I know of.
Okay. Great, thanks. Well, again, not to get, you know, head down the whole output of RecIF and everything. I just know that was some of the issues that we've dealt with in the past. So at this point, I think I would ask Robert and or Leslie to maybe come in and ask maybe some questions that they might have pending right now. I don't see anything in the published section for myself right now. Is that possible? Real quick.
Yeah, I think Paul had one more question, actually.
No, I think Abram answered the question about OSLC standard. He's right. Yeah, so we are pretty much a Magic Draw SysML system engineering house, and linking between Windchill and Magic Draw. I think there's something we would be interested in, and I think having the OSLC standard is probably probably the desired way to go for the RecIF in this case.
Hi. Yeah, so the one I had put in, and some of you have already spoken to it, and Katie commented on it, but what I'm really interested in, well, I'm interested in everything that you folks have said today, and I really appreciate it. we're really curious, and something that we all talk about, and we've talked a little bit about here, especially regarding requirements, but do you see us a future where you expect all of our standards developers to identify other components of a document, find the recommendations, take you right to the test, find the verification statements? How much do you expect us to break down all the many components of a standard? And this could be for any of our user guests. Katie, I think you're trying to answer me, but you may, no, but I think Katie was trying to answer.
I'm muted. I did it. Sorry.
Okay, good. Thanks,
Okay,
Katie.
Katie.
So what I was going to say is, yeah, I put my basic answer in there, but you know, in an ideal world with Denver Water, obviously we focused more on AWWA and ESTM. Now that AWWA has Envoy, having that ability to hyperlink, you know, between Envoy and Compass, since we have both platforms, that would be, you know, an ideal situation in our world. It is far improved having those platforms, but having a more having a bigger interchange between the two would help us, and it helps educate too. I think that's the biggest aspect. Is it's not just, you know, what do we use to write our specs from, but how do we help educate staff as well?
Well, I'll just say real quick, thank you to all our guest panel. You guys have provided a lot of good information. I know there will be more answers from them coming, so attendees could at least look forward to seeing that. And I'm going to turn it back over to Lakshmi, and thank you very much.
Thank you guys so much. Thank you, Steve, for moderating such an interesting session. So guys, that's a wrap. Thank you so much for attending our Standards Technology Forum, our first fully virtual forum. I want to once again thank all of our participants, our speakers, our guests, our customers for providing such invaluable insight to us as we maneuver through this technology world. We will be sharing on the technologyforum.org website the links to these presentations, as well as to the live recordings, so that for some of our friends, specifically on the other side of the hemisphere, that were not able to stay up past 4 a.m., as they said, to watch all of this, we are going to make sure that all of these are posted for you to review at a later time. Please check in at the website. We'll also reach out with some lunch and learns and webinars on some specific topics that were mentioned today, so that we can continue these important conversations. And we will be planning our next forum next year. So thank you again for everyone who's attended. I think we had really great participation, over 120 people at any given point. So thank you all. We really appreciate it, and have a great rest of your day. And we hope to see you again soon. Take care.